The second wheel to go on is this one. This consists of 5 parts, I think 5. Again, it's got a spacer on the back. It's got this intermediate gear next, and then it's got this driving gear, the drum, and the winding gear at the top. Now, I should point out that at this point that this component and this component both have one-way bearings on them, and it's got a one-way bearing on, both of them had, to facilitate the winding of the clock. Because what you want to be able to do on this is that this is where the weight's hanging, and so when the weight is pulling on this, it wants to be able to pull the gear around, obviously to drive the rest of the train. But when you're winding the clock up to wind the cord on, you want it to actually be free to move, and and that's the reason that we use the one-way bearing in there. This has got a one-way bearing in it as well, because it wants to drive the it wants to be driven by the shaft in the opposite direction to which this is being driven. And so we put the one-way bearing into this one, the opposite way round. Okay, so that's those two components, both built up in exactly the same way as this first component was, with the 2 pins driving through all the components to hold them in the right position. So if we put this back into place again, getting this the right way round, and I can never remember which way round it is. So we just put that back on and we will see. Yeah. And that's popped them all down using the spacers to get the right alignment. This is now engaging with the top gear. Okay. Keeping this cord out of the way, we finally come to the bottom gear. Exactly the same construction as the other parts. Sleeves, 3 components to the gear train component, and the shaft through the centre. This time fitted into this bottom hole, pushed into place, and we should now find that all of the gears are actually lining up. And if they're not, we will be in trouble. We've got the bearing covers, the bearings already in place, the winder component here. The winder is actually glued, solvent bonded to the shaft on the other side. The shaft comes through and goes into this winder component. This winder component has got a slot in it to engage the winder itself, so it can be wound. And it's actually pinned into position on the shaft. Now it's pinned in so that I didn't want to solvent bond this to the shaft, as you might get it bonded to the frame itself. So the little pin there is to hold those 2 components together to give you the winding. So I can take this now, and this is really the hardest part to the whole assembly, is to put this frame on and get all the holes to align. And if they fall into place, it will be slightly a miracle. I think that's it. Just check. on the rope. That's better. That's better. Now we can use these threaded rods. There's a lock nut on the back side and a little brass nut for decorative purposes on the front. So popping that through there, you can now put that nut into place. It's finger tight, that's all that's necessary. That one into place, again finger tight. That's the frame together. Now we can start to assemble the gears on the front. This very small gear that you see here fits onto this main shaft and is pushed down just clear of this surface, because this is the shaft that is going to revolve and give you the movement of the hour hand, sorry, the minute hand. So this is going to be driven directly by this shaft, and the purpose of this gear is to provide the gearing to drive the hour hand, so that it moves around in the appropriate time. So I'll pop this on first. It's really got to be a tight fit, this one, so it's actually quite hard to get it to go on. Not be too tight. That's fine. The other pair of gears that engage with that are those. You fit just there. These are actually solvent bonded together because they don't want to move relative to one another. So that drives that, and then that one drives this final gear with its little sleeve on, and that sleeve holds the hour hand, we put on now, and the minute hand, which goes on. So now I'll just point out here that both of these hands have been constructed with this hole a really tight fit on the shaft, in fact too small a fit really, and then a slot's been cut through to give that a bit of flex, so that when it's put on it's still a sufficiently tight fit to hold it in place, but it's not sufficiently loose that it will move without the gears. Okay, so I think at that point that's the clock built, and we can have a look at that being assembled onto the wall in a second. Just looking quickly what we've got here. This is actually the weight that's going to drive the clock. We've got a piece of clear plastic tubing. We've got two components, essentially the same. These are made from two discs, solvent bonded together. This one is actually welded, solvent bonded into the bottom of the tube, and this one, need to drill the hole out slightly so that it will fit more smoothly over the rod, whereas the bottom one needs to be a tight fit and solvent bonded. I'm using a sash weight, or a portion of a sash weight here, covered in blue tape because I don't like touching the lead. But yes, and this is cut off. It gives a weight of about 500 grams in total, which is sufficient to run the clock. So if we fit that in place, pop that over, press it down, that's the construction of the weight. Now for the pendulum, bring this into the screen. what you can see here is the pendulum, again constructed with two slices of acrylic, bonded together with two bearings fitted, one on either side, and then glued onto the pendulum rod. In this case I've used Gorilla adhesive to make sure that it stays in there, because it's got to stay there a long while. And at the other end we can fit the pendulum bob that we made earlier. Now it's been fitted now with a small screw, so if I push the pendulum rod through and up to approximately where it will work, the dimensions for all of this are on the drawings, and then just gently tighten it against so that the pendulum rod is now, or pendulum bob is now secured on the shaft. Now what we'll do now is to move to the other side of the workshop and show you it being fitted onto a board and hopefully working. Cool. Right, coming to the front frame, I've already assembled this. In fact, I've had to glue the dial onto the clock as well. Otherwise we can show it without. Again, I'm going to fit this pendulum to the back of the clock. Simply get the bearing to engage on the support, push it into a reasonable distance so it's not catching on anything, and then we can screw it into the board. Now this clock ought to be kept vertical, really just using a square to make sure that this front face is in the vertical. Otherwise it may upset the initial settings of the escapement. If it isn't exactly vertical, the pallets may not engage equally. Although if that's the case, you can still adjust the pallets so that they do work. There we go. Just make sure we're all tight. Check that the load is being taken. And I'll engage the weight onto the end of the cord. And now wind the clock. As you can see, the clock as it stands at the moment will run for about 10 hours, but it's slightly lower than it needs to be. Naturally you'd want the centre of the dial more or less to be at eye level, so if we moved it up to that you could expect to see it running for 12 hours. If you wanted it running any longer, you'd have to add a pulley system in, and all that means is that you would run the cord through a pulley mounted down here somewhere, and back up to a fixed point on the frame, and then hang the weight from the bottom of the pulley. That will double the length of the time that you'll get the clock to run. So you'll get a full 24 hours out of a single winding. Well, for the time being, that's it. The clock is complete.